So, friends, in this course on risk conscious operations management for complex engineering system, this module is probabilistic security risk assessment, and we have discussed introduction of this topic, that is PSRA, and then threat assessment. And now this is the third lecture on assessment of physical protection system and modeling. And modeling also is related to or the assessment is related to assessment of vulnerability, because physical protection system provides the security resilience or resilience to the threat, any incoming threat, and converse of it is if they are not adequate, then plant vulnerability will come into the action. So, this is how it is. Let us see how plant physical protection system, how they should be designed, what is the philosophy that can be used for designing this system, what are the commitments that should come from operation and maintenance, and then other security aspect that includes even threat aspect also. So, threat is the subject which gives birth or existence to the physical protection system. So, once, like in previous topic we have said, threats have been characterized: design basis threat, hazard, potential, provisions. So then we have a physical protection system, and in designing a physical protection system, the defense in depth provides the major role in terms of implementing the redundancy, diversity, addressing human factor related issues, having physical boundaries for security assessment, barriers, those comes into the picture, and that is how the defense in depth is characterized. And then as it is there, human factor is a very, especially in security assessment, it becomes more important because the vigilance and surveillance, they again become more intense in security assessment. During normal course, other physical protection system like equipments, barriers, they will be there, but any vulnerability or exploitation of these barriers can happen over a period of time, and that if surveillance is good or vigilance is good, it can be detected, because for protection security system, detection is the starting point. So, if things are detected well in time and adequate delay, inherent delay has been provided into the system, we can say not half the battle, but a good amount of work has been done as far as the site characterization is concerned, and security culture characterization is concerned, because human is at the center of security culture along with the organization. Hardware and physical protection involves barriers that include provisions of only authorized entries, screening, communication, electronics, then detection system, then sensor system, then various computers that are linked there, then their data logging, all these things, and then of course performance evaluation. And to ensure the effectiveness of this, the testing and regular drills are very important. So now whatever data collected from this provides us a very critical input which is required for performance of physical protection system or assessment of vulnerability, whether it is going down or we are able to make it stronger by removing the weaknesses into the system. Now, what is vulnerability? If I have to define, there is a simple definition here is gap area in performance and objective function. Objective function is to keep security level is equal to 1. That means perfect. Any gap area is there, the on lower side is it introduces vulnerability, and these elements include flaw, latent and active faults, limitations or weakness in physical protection system, design, operation, maintenance, procedures, virtual entities, and including surveillance system that can be exploited by internal and or external adversaries. And if we can add here human factor, because human performance also is important to assess the uncertainty. So that means for humans also, either on annual basis, there is a performance check and a report which tells us that there is no gap area, and the attention level, awareness level, focus of a person, or who are involved in protection, physical protection system maintenance, it is as per, and these guidelines should be evolved, benchmark should be evolved, so that vulnerability becomes a visible and rational indicator, and anybody can interpret it, understand it. Okay. One of the major objective of PSRA, when we do probabilistic security risk assessment, even though vulnerability is one of the building block of PSRA, but then once the analysis results shows the vulnerability level, it is an indication of plant's weaknesses. So of course there will be some strength, there will be some weaknesses. Strength means resilience, and vulnerability means they can be exploited in the plant, and then you have immediate motivation to improve upon these things. And if we cannot improve the infrastructure, we can make some redundant provision so that the vulnerability is reduced and we achieve a benchmark. Now, it is just a very simplified presentation slide. The site is one of the most important parameter, because if I am locating an asset where the air route and there are three routes mainly, air, water and land. So the site selection should consider all these things, and then should have some characterization in the context of security or vulnerability. Then identifying the boundaries. Normally most of the safety critical systems, they have on-site, off-site, and then protected area, and then controlled, like it has been listed over here. So this is off-site means public domain, and then limited area where limited occupancy can be there, protective area, controlled building and controlled room. So this is heart of the plant, okay, and then the plant itself. So it's just demonstration, some target vulnerability or a target is here. So many barriers they have to cross, because at every boundary there will be some security post. So these are all protective measures. So and that's why they are referred as physical protection system, because first the site layout, then how the redundant provisions have been provided, and how detailed designing has been done around location, so that outsiders entry, either material or person or even arms should be prohibitive, and that should be demonstrated actually. Requirement of physical protection system should consider the above things and all, and then all these provisions together, they give the definition of design basis threat and vulnerability. PPS design and its effectiveness general can be worked out. So these are very important considerations as far as the vulnerability is concerned. Any weakness in the physical protection system will generate a component of vulnerability. So this is, we are talking about the physical protection system. We have said physical areas, but we'll see in the last lecture cyber security. It is a different connotation actually. It is in fact computers or systems or electronics get infected. Okay, so the best layer is there are layers which are prepared, which are isolated from one another, firewalls, then having different servers for internal and external purpose, so that the cyber threat can be reduced to the minimum. But of course, there are files which are transferred from one computer to another computer. Even there should be protocol for those kind of things, but that we'll discuss in the last lecture. Now, risk of sabotage. Okay, risk of sabotage can be defined as the probability of or possibility of deliberate attempt action to harm an organization. Okay, and sabotage might involve destruction and tends to be at times having a potential for serious consequences, either short term or long term. So if a threat is stopped, we are safe. If threat and the stopping threat, a non-stopping threat is not like a 0 or 1. There could be in between stages. So it's a fuzzy terminology. Okay, so and protection should be there at all the levels. So this is what we are trying to expand the definition of sabotage over here. Based on insight from documents, some of the factors, mainly the security culture, can prevent sabotage as follows. So we discussed in one of the slides. Vigilance is the one of the thing, and this 24/7 and in perpetuity it should be there. And in security matters, one should be borne in mind. If it has not happened in last 30 years, so it will not happen. No, the way it was there at time vigilance, any weakness in vigilance could be a vulnerability in itself. So it can happen now, it can happen tomorrow, and then whatever lessons are happening around us, they should be our continuous motivator for being the vigilant. A proactive approach, we don't have to wait for anything. If we feel it, it has to be done, because we are dealing with a matter called security. Ensuring organizational resilience in perpetuity to prevent occurrence of and mitigation of capability of sabotage. So as I said, in perpetuity, that means there is no time or and 24/7 sort of. It should be ensured that the security measures, then and then mitigation measures also are being its capability being checked against a given threat. Now let us try to understand from here which are the major elements that comes between probability of threat success. There is something called threat success. Each and every threat is not a threat. When a threat becomes success, it becomes part of our document. If there is some uncertainty to be on server side screening of the events, this can be taken care of. But this particular parameter is very important, threat success. Here success is a different meaning. Threat potential we can say actually, or threat damage potential we can call. So once the threat has become reality, now what next? Then the next term is neutralization. Once threat has come, then all protection system we are meant security provisions we have over here, it should ensure that it is neutralized. Okay, and then the third is, if not neutralized, then damage potential, how much it will be. Okay, so this is threat success is equal to 1 minus non-neutralization, that is this term, not neutralized, and then the damage conditional probability of damage given over here. So now here we can collect data on PS, that is threat security, neutralization capabilities, damage postulation can be done, and we can have for every threat which will become successful, and this becomes the part of our screening methodology itself, because all we are doing is postulation in our assessment exercises. So PN is the probability of detection, interruption, and neutralizing the threat. Okay, and 1 minus PN is the unsuccess story. PD is the probability of damage when the threat is successful. Okay. Now this probability of neutralization is very important, and it is basically a strategic factor actually, and advanced or proactive provisions are required considering that the threat has become neutral, and then you saw in the definition all those critical definitions should be validated. Okay, in one of the event tree we'll show you what is the role of threat, what is the role of detection, what is the role of delay, and then what is the role of protection measures, and finally what are the frequency scenario and damage potentials. So advanced maintenance of physical protection system includes trained security staff, availability of physical protection system is key to the health of physical protection system. Physical protection system should be based on graded approach, based on these are IAEA guidelines, International Atomic Energy Guidelines, risk informed guidelines, and graded approach comes from risk informed input actually, and probabilities. Probability of neutralization of threat is a function of detection, then there is some one more factor, delay, interruption, and then T capacitor of whatever damage potential was there. So we are talking about in short, there is a limitation here. We cannot go to the very specific aspects. Only thing is, when we work on the project, we have to touch upon all the aspects and details. So here these are indicative, but for learning purpose and for preparing ourselves as a safety security person or expert, these are sufficient, and rest of the knowledge is available in the public domain. Now one very important exercise or documentation, it is called risk-based security audit. Audit is a very elaborate procedure. It requires a lot of, you would have seen financial audit, you have seen in engineering many jobs, project audits, they go on. So like it is a risk-based security audit. That means a checkpoint or an exercise or a procedure which checks the effectiveness of various provisions to ensure that the security systems in this case they are available and they are having very high reliability. Okay. So and why risk based? Because when we do the audit, we try to see because like it happens probably I have discussed this in service inspection for the plant. The systems are inspected or checked periodically to ensure its integrity, its health, and if any defect is found, then it is addressed. The issue is addressed either by repair, replacement, or some alternate provisions like alternate path or whatever. But it is addressed. So similarly here also, but then there it is very tricky which part to be done. So the experience in risk-based ISI or risk-informed ISI is that the list of item to be inspected or to be inspection to be carried out, they remain to 25 to 50% after mapping this risk-based procedure. So same thing applies here also. All the points are not important. The points which have maximum potential or for vulnerability or damage or effectiveness of physical protection system, those only need maximum attention. So rule of 20/80. If 20% of the component or 30% of the points if you address, you should achieve 80% coverage. Okay. So here also it is same thing. So that's why risk based audit is there. It identifies and prioritizes the number of points that need to be checked or maintained, or any repair has to be done. So what it is doing basically is, it is telling us that okay, importance number 1 to importance number nth items. Now you choose which are the component you have to take, and there are, if not guidelines, there are indirect measures that are available, and many people have used this risk based approaches and let us get benefited in terms of improving the security and effectiveness of our maintenance measures. Now security audit is an integral feature of assessment and preparedness. Of course, the way in-service inspection is done, here also checkpoints are there. There is a checklist, and it is a periodic activity. It could be annual, it could be alternate years, it could be periodic 6 months, but then there is a periodicity attached to the audit. Only domain and this kind of exercise are performed by a team of qualified expert. As only security expert can tell what is lacking. Of course, if there is some electronic issues, then electronic expert also can come, but they are working in the interest of security. So experts involvement is very important to make the audit more effective. Security audit is performed 3 levels of proactive. And then there should be a level. First it should be proactive, need based, then internal audit, and authorized or independent regulatory audit, where the outside agencies like regulators which are independent of the plant, they are involved. Okay. And then checklist. The strength of the checklist will determine how the coverage plant coverage is going on. If coverage is poor, the audit will not be good. And data and insights that are available from audit will be a very powerful tool in reducing the uncertainty in our security modeling and assessment, because this is a closed loop system. And then compliance and reporting, because once a third party or regulator visits your site and then they provide certain point, over the year this has to be reviewed how they have been met, and if anything is pending. If anything is pending, why it is pending. So with this holistic system and based on the risk criteria, it provides a very strong mechanism to implement the surveillance programs. Example of physical protection system, just for the sake of completing, because we had digital ID card scanners, human scanning at the exit location, entry and exit location, X-ray scanners. You can see on airports and all, these things are closed circuit cameras are available, audio visual alarm detectors, security staff with the scanning equipment. Again, human factor, I consider these are the most important factor here. Audio and digital PA system, computer with firewalls, movement of electric operated to blockers. This is cyber security. Communication system, telephone, walkie-talkie operation system, and there are many advanced systems which are there. Then we have barriers, computer, campus boundary, fencing, checkpost, and of course audit is a very critical exercise for checking the healthiness of this product. This list is not exhaustive. There are many more we can see in the open literature. Then resilience of physical protection system objective. Prevention of threat, first of all, it should be the deterrent actually, Then second objective of having a strong physical protection system, and its objective is it should be able to detect how in time such that our reserve security forces can be put into operation, and we are the checkpoint, critical point, we are able to neutralize the threat, and then this has connotation to detection, delay and response, and then mitigation of consequences. So if at all some damage has taken place, limited amount, how mitigation that through accident management can be made, and these are the very important indicator, and they always form part of any audit or any surveillance or any maintenance or any operation monitoring surveillance and all. So this has to be seen. The threat we had seen in second lecture, vulnerability we saw in previous lecture. Of course, I have not given the detailed calculation and technologies and nuances, because we are having this thing lecture only for academic purpose. Okay, so these two metrics now we understood, and they are central to arriving at the estimate of risk. What level of risk is there in the plant, and what improvement to be carried out. In previous lecture, we learned about the threat modeling and analysis including. In this lecture, we discussed vulnerability. Now, in next lecture, we will go on probabilistic security risk assessment.